Right, in this video, I'm going to be going over your optimizations and related rates quiz review. Now, what I'm going to do for this review, since there was so much writing on the review itself, I trust that you have the review in front of you at home while you're watching this video. So I'm just going to write on a blank Smart Notebook page and refer back to the actual paper review. Okay, so make sure you have your paper while you're watching this video. All right, so number one, it says the choice room is no longer large enough to hold all of the miscreant students that keep getting sent there. Thus, Mr. Carroll has come up with a brilliant solution. He will take 350 feet of barbed wire electric fencing. Then he will go to Memorial Boulevard and using the highway as a side of a rectangular fence and a rectangular holding pen for the students sent to the choice room. He doesn't worry about whether or not using the highway as a barrier is a good idea or not. Frankly, if a student were to wander into the highway, nature will take care of itself and all will be well. Find the dimensions of the new choice room area that will produce the maximum holding area. All right. So for this one, what we're going to have to do is it's going to be the problem similar to having a river on one side and making a three-sided fence. So I know my drawing's terrible. Here's Memorial Boulevard. Okay. And then our fence is going to be here. Okay. Our fence is going to be here. So we'll call this a length, this a length, and this the width. Okay. So we know we have 350 total feet of wire. Okay. We know our perimeter in this case is only going to equal 2L plus W because we don't need to fence in the side of the highway. Okay. And we know that area equals length times width. Okay. So now we're going to need to solve down for a single variable. So let's take our perimeter here and solve this equation down and get a single variable. So we know this is going to be 350 equals 2L plus W. So I'm going to subtract the 2L from both sides to keep me from having to divide by 2 later. So 350 minus 2L equals W. Now we've solved for a single variable. We can substitute back up here into the area and get rid of one of the variables. So now we know that the area equals the length times 350 minus 2L. Okay, because we took W and substituted in for this W. Now we need to take the derivative of the area. So the derivative of the area, I'm sorry, let's not take the derivative yet. Let's distribute through before we take that. So area equals 350L minus 2L squared. Now take the derivative. So the derivative of the area will be 350 minus 4L. We need to set this equal to 0 and solve for L. So 0 equals 350 minus 4L. Add the 4L to both sides, so 350 equals 4L. Divide by 4, divide by 4. So L equals 87.5 feet. Okay, so now we have our length. So now we just have to go back, plug into the area formula, and plug into the perimeter formula, and find the width. You can use area if you want to. Actually, you can't because we don't know the width yet. So I'm going to plug into the perimeter. Perimeter equals, well, let's take that one step further. Let's say 350 equals 2 times 87.5 plus W. This is 175 plus W equals 350. So subtract 175 from both sides. And our width equals 175 feet. Okay. So the length and width of the new choice room area it'll be 87.5 feet long by 175 feet wide. And that will give us the maximum area. Okay. All right, moving on. Number two. Number two says a magician who moonlights as a serial killer is planning on carrying out a, a hideous murder of his gorgeous stage assistants by performing the cutting the beautiful woman into act only for real. However, to accomplish this trick, he will need to have a rectangular box in which to place the woman. Since she is, since she is 6 feet tall, the box will need to have a length of 72 inches. Since the woman will be cut up into pieces, the width and height don't particularly matter, but the overall volume will need to be 3,820 feet, inches cubed. The, the box sides, having been elaborately painted for the magic show, will cost $5.34 to build, while the lid and base are less decorated and will cost $2.18 to build. Find the dimensions of the cheapest box and give the actual cost to build the box. Alright, so that's a lot of wording, but here's how you do it. First of all, we know the volume of the box will have to equal 3,000, that's a 10, will have to equal 3,820 inches squared, cubed. And we know that the cost, and we're also going to have to figure out the cost of the box in a minute. So we know volume equals length times width times height. Okay. Now let's go ahead and solve this for a single variable because we're going to need to anyway. So volume equals 72 WH, which the volume is 3820. All right. So now let's divide by the 72. Divide by 72. So 53.06 equals WH. If you remember back from the videos, this is one of those aha moments. Divide by H, divide by H. So the width equals 53.06 divided by H. All right. Now we need to figure out the cost of this box. Well, we know that the length is 72 inches. So we know that the front and back face, so there's going to be two of them, the front and back face, the total area is going to be 72 times H. And then you have to multiply that by what it costs to build it, which is $5.34. Plus, we know that the sides, there's going to be two of them, and that's going to be 72 times W times 2.18. I'm sorry, that's top and the bottom, not the sides. Plus, and now the sides, there's going to be two of them. It's going to be width times height, and those are going to be times the 5.34. All right. So now we can substitute in for some of these variables that we know. So C equals, okay, we don't know what H equals, so we'll just leave H in here, and that's the variable we're going to solve for. Plus 2 times 72. Now, width, we solve for W over here. Width is 53.06 divided by H times 2.18 plus 2 times length times width times height, which is 53.06 times 5.34. Kind of cut it off there. All right. Now, just simply simplify this together. The total cost is 768.96 times H plus 16,656.60 divided by H. Yes, that's right. Plus $566.68. All right, now that we're here, okay, we have one variable. We've got it simplified as much as possible. Now we're going to have to take the derivative. So C prime is 768.96 minus 16,656.60 H squared over H squared. And of course, the derivative of this is 0. If you're wondering how I got this, if you do quotient rule on this, remember it's low d high is 0, minus high d low is 1. So this comes out to minus this ridiculous number divided by H squared. All right, now in order to solve for H squared, we're going to set this equal to 0. And I'm going to kind of combine two steps here. I'm going to set this equal to 0 and add this across to the other side at the same time. So 768.96 equals 16, that ridiculous number, over H squared. Now, we're going to need to multiply both sides by h squared and then divide both sides by the 768.96 in order to get h squared by itself. So h squared is going to end up equaling the ridiculous number divided by 768.96. All right. Now this ridiculous number here comes out to be about 21.66. Okay. So h squared is 21.66. Take the square root of both sides to get your height as 4.654 inches. Okay. So now we know the length it has to be and the height it has to be. So now all we need to do is plug this in to the volume equation and we can find the width it needs to be. Okay, so 3820 equals 72 times 4.654 times W. Divide both sides by the 72 times 4.654. Divide 72 times 4.654. And W comes out to be 11.4 inches. Okay, 11.4 inches. Now, it wants the total cost of the box. I'm not going to go through the time to do the total cost of the box, but if you remember, this equation here represents the total cost of the box. So all you have to do is take your 4.654, plug it in for h in these two spots, and solve it out. Your total cost, when you do that, should come out to $7,724.06. But now keep in mind that this decimal here, it may vary, it'll vary a little depending on how much you rounded up here. Okay? So as long as you get the dollar amount right, the change really is not going to matter that much. Okay? So the important thing is to make sure you get that it's going to be $7,724 and some change. Okay? Because like I said, depending on how much you rounded, the change will vary. Okay? Number 3. It says a metal extension ladder is leaning up against the side of a house. As a painter is working on painting the trim of the house, his weight pushes the feet of the ladder firmly into the ground. After a while, a bee buzzes by the painter's head, and in a fit of panic, the painter accidentally knocks open the extension release on the ladder, causing the ladder to begin collapsing inward. If the top of the ladder is sliding down the wall at a rate of 2.3 feet per second, how fast is the ladder collapsing at the exact moment when the top of the ladder is 14.3 feet from the ground and the bottom of the ladder is 12.9 feet from the base of the wall? So again, here's my wonderful drawing. Okay, this is the ladder part. And the ladder is sliding down the wall at a rate of negative 2.3 feet per second. Okay, and then we need to know how fast is the ladder collapsing when it is 14.3 feet above the ground, and the base of the ladder is 12.9 feet from the house. Okay, so now, since we have a triangle, let's call these side A, side B, and side C. We need to find C. We're going to use A squared plus B squared plus equals C squared to find the third side, since it is a right triangle. I'm not going to do all the math right now, but C comes out to be 19.3 feet. That is how long the ladder is at this exact moment. So now we need to take the derivative of this. This is going to be 2a dA dt plus 2b dB dt equals 2c dc dt. Remember, this is a derivative of c with respect to time, derivative of b with respect to time, derivative of a with respect to time. Now you can divide all of this by 2 to get rid of the 2's. So we have a dA dt plus b dB dt equals c dc dt. Now what we're actually looking for is this, the dc over dt. That is what we're actually looking for. We're given dA dt and dB dt as well as a, b, and c. Well, we weren't given c, but we found it. Okay? So now, a is 14.3. dA dt is the negative 2.3 plus b is 12.9. Now, dB dt, you might be wondering, we don't have that, even though I said it was just given. Well, if you remember, it said that it pushed the feet of the ladder firmly into the ground, which means this length, this 12.9, is never going to change. When the ladder hits the ground, the ladder is going to be 12.9 feet long. Okay, this is never going to change. Since this is never going to change, the derivative of b with respect to time is 0 because it is not changing. And that equals 19.3 times dc dt. Okay, this is pretty much gone because you're multiplying by 0. So that gives us negative 32.89 equals 19.3 dc dt. Divide by 19.3. Divide by 19.3. So dc dt, which is the rate at which the ladder itself is collapsing, is negative 1.704 inches or feet per second. Okay. Now keep in mind again this decimal, the decimal here, the 1.70 will remain the same, but this 4 will vary depending on how much you rounded. Okay, I think the entry key on the back says 0.08. Yeah, the key says 0.708. But like I said, this 4 will vary depending on how you round it up here. Okay, so as long as the first 3 are right, the fourth one you're not going to get marked off on. Okay? All right, now let's go to number 4. It says a circle of blood caused by the grievous wounds caused to a certain old professor sitting in a mangled wheelchair after being ravenously bitten by a T-Rex forms the shape of a circle. If the circumference of the circle is changing at a rate of 9.68 inches per minute, what is the rate at which the area of the circle of blood is changing when the area is exactly 2 times the circumference of the circle? All right. So now how do we do this? Well, we know circumference equals 2 pi r. All right. We know that area equals pi r squared. And we know that our circumference, 2 times our circumference needs to equal our area. So pi r squared is going to equal 2 times 2 pi r. Right? Because that's what it says in the end, is what is the rate at which the area of the circle of blood is changing when the area is exactly 2 times the circumference of the circle. So that's why I put this in here. Now, we're also going to use this equation here to find the radius of our circle, because if you notice, we only have one variable. So let's do that. First, we're going to divide both sides by pi. We're going to get rid of pi. So r squared equals 4r. Subtract the 4r from both sides. So r squared minus 4r equals 0. Factor out an r. So r equals 0 or 4. Because if this is 0, the whole thing is 0. If r is 4, the whole thing is 0. Well, the radius equals 0 doesn't make any sense at all. So in this case, our radius is going to be 4. All right. Now, since we're looking for how fast the area of the circle is changing, we're going to leave this equation alone for now and go to this one. We're going to take the derivative of the circumference equation. So dc dt equals 2 pi, derivative of r is 1, dr dt. Okay. We know dc dt is 9.68 inches per minute. That equals 2 pi dr dt. Okay, now we need to find dr dt because we're going to need to plug that into this equation. We do that by dividing both sides by 2 pi. So dr over dt equals 1.541. Okay, equals 1.541. Now let's take the derivative of the area because we're going to plug this in and we're going to plug the radius in. So dA dt equals 2 pi r times dr dt. All right, this is what we're looking for, dA dt. And that's going to equal 2 times pi times 4 times dr dt, which is 1.541. So that equals 8 pi times 1.541. So dA dt is 38.73 inches squared per minute. Okay, again, the decimal will vary depending on how much you rounded up in all of these steps. Okay, so it says, what is the rate at which the area of the circle of blood is changing when the area is exactly 2 times the circumference of the circle? It's changing at a rate of 38.73 inches squared per minute. How do I know which inches squared per minute? Well, area, your units are squared. So this case is inches squared per minute is your units. Okay, this is all there is to your quiz review. And in fact, your quiz will basically be the same thing with different numbers. So as long as you can do this quiz review, you should have no problem on tomorrow's test. All right, so make sure you watch this video as many times as you need to understand how to do all 4 problems on this exam. All right, so good luck and see you tomorrow.